Guys, today we are back with another problem, and today's problem is finding the number of ways to the nth stair. So this is a very simple problem. They have given it a medium problem because it requires the concept of dynamic programming. If you want to implement dynamic programming, you can. If you want to implement recursion, you can. Okay, or if you want to implement a normal mathematical approach, you can do that as well. Okay, so the best optimized solution will be the DP approach. Okay, but I'll come to this later on. Okay, so the first, let us analyze the question. We will be given a stairs, number of stairs. So it is saying that, say for example, this is one stair, 2, 3, 4. That means n equals to 4. Okay, and it is saying that a person can jump to the top of the stair from the base of the stair to the top using the combination of jumping one stair, or it can jump one stair or two stairs. Okay, so I hope I made my point clear. So if you guys analyze this, so what are the possible combinations I can make to reach to the fourth stair? I can either take 1 1 1 1. So if you add up this, you will get a 4. Okay, I can take 1. Okay, I can take 2 and 1. Okay, so 2 3 4, I can get a sum of 4. Okay, I can take 2 2 0, then also I can get a sum of 4. Is there any other possible ways? No, there are no other possible ways. Total number of ways I did 1 2 3 equals to 3. So if you see the answer, the total number of ways is 3. Okay, the total number of ways is 3. Total number of ways is 3. So how we can do this? We can do this using a very simple function. So if our function is containing the total number of stairs n, we can just write return n by 2 plus 1. Okay, so this is the mathematical approach. So what is the dynamic programming approach? Let us come. What is the dynamic programming approach? So basically we'll be having we can say this is our class solution. We are having a class solution. We can create a memoization table. So I can say int memory array. Okay, after that, what is the function we have? We have the function n. Okay, and memo equals to new int. I can create n plus 1, the size of the DP table, and we can return the function ways of n. Okay, now you will tell me what is the function ways. So I can have a function ways. I will make a function ways where I'll pass the value n. Now I'll check my base cases. If my n is equals to 0, then I will return 1. That means if my n is 0, means there are no steps. Okay, if my total number of stairs is 0, then what can I do? I can either use 1, right? I can only go forward. That's the reason I'll be using return 1. If my n is equals to 1, in that case also I'll be returning a 1. Okay, but what if it is not a 0? Okay, it is not a 0. Then I can say my memoization table of not equals to 0. Then I can return memo of n. After that, I'll be recursively calling the function. So I can write memo of n equals to 1 plus the name of the function is ways. So I can write ways of n minus 2. Okay, and we can finally return memo of n. Okay, so let us just check. So this is the dynamic programming solution. We can compile this solution. Okay, we can compile the solution to check whether it works or not. So if I submit the solution, you will see it will pass all the test cases. Or if I don't want to use this method, I can use the simple mathematical approach. I can just write return n by 2 plus 1. I can just write over here return n by 2 plus 1. I can just compile. I have missing a semicolon, so I have to compile. Okay, I have to submit the solution. So you can remember this formula as well. It's very helpful for many of the interview questions. So yeah, that was today's problem statement. It was asked in Acolyte and Amazon maybe a years back, because nowadays Amazon don't ask this type of questions. So make sure you guys like, share, and subscribe. Whenever you are seeing that number of ways, that means recursion is used, that means dynamic programming is used. Or if you know the short trick of the formula, you can apply that as well. Make sure you guys like, share, and subscribe to the channel. Thank you so much.